Hello, it's John again with another video. In the previous video I was talking about the addressing modes in depth and to the point that it became a half an hour long, and so this video is a continuation of that, where we're going to go talk in depth into the instruction set and how it affects the 6502. So here goes. So the first instruction we're going to look at, which you should be familiar with, is the load accumulator instruction. And as I described before, it takes memory and loads it into the accumulator. And this instruction has some side effects with it as well, because it modifies the status register as well. It modifies the negative flag and the zero flag. So if you load the accumulator with a number, it will actually set those statuses as well, and we can demonstrate that by in the code. So if we go into the code, so here we go, we've got load the accumulator with 90, and what I'm going to do is I'm just going to create some more. So we're going to load the accumulator with 0, we're going to load the accumulator with 10, load the accumulator with 90, and load the accumulator with FF. So we're going to send that to the debugger so we can run it step by step. So here we are in the debugger. This is the start of our program. So we're going to jump into the first instruction. So here we go, load 0. So straight away we've got 0 into the accumulator and the 0 flag has been set. And it's saying that we've just loaded a 0, and we can test that. We can actually branch on those flags just by the load. So if we go on to the next one, which is load 10, so now we know the accumulator's gone to 10, the 0 flag is no longer set. So we know now that the number that's just been loaded in is a non-zero value. If we go to the next instruction, which is now set to 90, the negative flag has been set. So we know that that is a negative number in terms of 2's complement. So 90, if we, let's get the calculator up. If we type in hex 90, we can see that the most significant bit is set on, and in 2's complement that means it's a negative number. So in 2's complement this means negative 32. Okay, and that's why it's set the negative, and we can branch on that by using the branch if negative or branch if positive. So if we load the next instruction, which is FF, which is maxed it out completely, the only thing that's set is that in fact it thinks it's a negative number. So we have just loaded values straight out of the program into the accumulator, but this effect will happen if you loaded values from memory using any of the addressing modes. Okay, so we'll move on to the next one, which is load the memory to the accumulator with carry. And what this does is it takes the value of the accumulator, adds the value coming in from memory, and then adds if the carry is set or not, and the result is left in the accumulator and the carry. But it also affects the negative flag, the 0 flag, the carry flag, and the overflow flag. Well, I've already told you what the negative flag is that if the most significant bit of the accumulator is set, then it will class that as a negative number. If the end result happens to be 0, then the 0 flag will get set. The carry flag gets set if it adds 2 numbers together and the result is bigger than 256, because that's the maximum number you can have. So if you add 255 plus 1, you get 256, or in other words, you get 0 plus the carry. So what we're going to do is we're going to clear the carry. We're going to load the accumulator with 0, and then we're going to add something very simple, 1. Okay, Then we'll see what the instruction is. Then we're going to set the carry, and then we're going to add another 1 and see what the end result there. Then we're going to we'll add another 1, but this time we'll add the maximum value we can have, which is FF, and then we'll add FF again. So hopefully we'll see all the different states of the add accumulator. So here we go. So we're going to jump into the first one. So we're going to clear the carry. The carry's cleared already, but we're just making sure it's clear. Load accumulator with 0. So straight away the 0 flag's highlighted. Then we're going to add 1. So now the accumulator's set to 1, and we have no effects on here, because if you think about it, we're not 0 and we're not a negative number. So then we're going to set the carry this time. So there you are, carry's set, and we're going to add 1 again. But hang on, it's gone to 3. 1 plus 1 is 2. But the reason why it's gone to 3 is because it's added the carry. Because remember, it's accumulator plus memory plus carry, and because the carry was set to 1, it's now 1 plus 1 plus 1 equals 3. Do the next instruction, which is FF. So we're going to add FF. So FF onto this is going to blow it, so it should come back with 02, but the carry should have 1 in it. So let's try it. There you go, 02, and the carry flag is set. So it's saying that we've crossed that page boundary in a byte format. But the next instruction is add 255 again. So straight away, 02 plus 255 is a big number. So the next instruction is AND. So AND is going to take the accumulator and do a logical AND with the memory and put the result back into the accumulator. And so it's going to set the negative flag and the 0 flag if it happens to be a negative number or a 0 number. Now what happens in an AND is that it's basically this. So if you've got input A and input B and you want output C, an AND is when both inputs are 1, the result is a 1. Any other state of result will be a 0. So 1 and 1 equals 1. 1 and 0 equals 0. 0 and 1 equals 0. And 0 and 0 equals 0. So in a typical machine language byte scenario, if we have 1001 0011 and AND it with 001 00101, the end result, if we do it byte by byte, is 1 and 0 should 0, 0 and 0 equals 0, 0 and 1 is 0, 1 and 0 is 0, 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, and 1 and 1 is 1. So the end result will be 1. Okay? So let's figure out what those numbers are. So the two numbers we want, so if we're going to binary, so it's 10010011. So that's 93, and the second number, so it's 9300100101 is 25. 93 and 25. So they're the two numbers we're going to use. So we'll load 93 into the accumulator, and then we'll AND with 25. Move that down, and we'll put a breakpoint there so we know when to stop. So if we debug this now, we should end up with the final result of 1 according to our Boolean logic. So here we go. So we're going to jump in, clear the carry, load 93 into the accumulator. We're going to AND it with 25. So the end result is 01. There you go. And that is an AND. It's just matching the bits up, and if two ones align, then we get a 1. If anything else, we get a 0. So the next one instruction is shift left 1 bit, and what this does, it shifts every bit up 1, right? So it puts a 0 in this bit, and then bit 0 becomes bit 1, bit 2, and moves across, and then bit 7 gets put into the carry. Okay, so if we use the same number as we've got here, which is 93, what it'll do is it will shuffle everything across, so I'll end up with a 0 there, and then this 1 gets put into the carry. Alright, so we'll end up with a number, whoops, in fact, let's copy that and put it in here, paste. So if we take this number, and we'll get rid of all that, it will put, so what it does is, there was a 1 there, wasn't there, at the end? Yeah, better put that back in there, that's it. So what it does, it's going to shuffle everything across, so it puts a 0 in the bottom there, but then this 1 gets put into the carry. So as you can see, the 0 comes in the bottom, everything gets shifted over, and then 1 comes in the carry. So we know that 93 is the number that we're going to put in, and the number we're going to get out, if we go into binary, is 01001100, which is 4C. So we should get 4C out of it if we do an ASL on the accumulator. So that's what we're going to do. So we're going to clear the carry, load 93, and then we're going to do an ASL. So if we run into debug mode and we step into it, here we go, clear the carry, load 93, and we should get a 1 in the carry, and this become whatever the number was before. Now what? 26, and we have 1 in the carry. So was it 26 that we said? We must have got the wrong. So hang on, was that 93? Let's put it in the calculator. So 101001100. Oops, clear. 101001100. Ah, it wasn't. So we need to put 93. What's 93? Right. Let's put that back to what it was. So 93 is 100100. Right, okay. Uh, 10010010010011. Is that right? 10010011. Yeah. So when we shift it over, that goes into the carry, and we put a 0 in. So we should end up with what we've got, which is 00100110. You know, 26, and that's what we got in here, isn't it? Debugger 26. So if we logically shift it again, then 0 goes into the carry and it moves across. So we can do that. We'll change the code, close that down, change the code, we'll put another one in, debug it, step into it, clear the carry, load 93. We know the first one goes 26 and the second one becomes 4C. So what we've done is we shuffled it up again. So 0 goes into the carry, and we add another one in there. So the number, it says, was 4C. So if we go into binary and we go 01001100, I forgot to clear again, 01001100, 4C. So that's shifting the bits over, yeah, from the original number of that. Alright, so the next one is branch if carry clear. Well, we've got them already set down here, and what it is we've got a number of branches down at the bottom here, and what we could do is we can easily select, we can easily do this because we've cleared the carry here. We can do branch if carry clear to clear carry, and we'll set clear carry to be here, and we'll put a break in there, and we'll set carry, we'll put a break there, and what we'll do is we'll branch if carry set to set carry. Right, and what we'll do is we've cleared the carry here, which will jump to the carry clear, but we'll set the carry here, and we can do both tests in both goes in the same way. So debug it, we'll jump into it, clear the carry so it's cleared, branch if carry clear, straight away branches to here because the carry is clear. If we go back to here and run into it, branch if carry set, and that's jumped to that because the carry was set, and that's all that the branch does. So this test to see if the carry is set to 0, it doesn't affect the registry anyway, and then jumps to the point if the carry is set, if the carry is clear. And branch if carry clear is it jumps when the carry flag is set to 1, but still again doesn't affect. Next one is branch if result 0, so it branches if the 0 flag is set to 1, or branch if the result is not, or in this case branch if result minus, which is the negative flag, is equal to 1. It branches if the negative flag is set to 1. Right, the next one is bits. Now this is a really strange one, because what it does is it takes the accumulator and then ANDs it with memory, yeah, and then also takes bit 7 and bit 6 of the memory and stores it into the negative flag and the overflow flag. So it's pretty strange the way it does it. I've only used it once or twice. It's not something that I use very often. But basically what it allows you to do is to AND your accumulator with the memory, but the overflow flag and the negative flag is taken directly from the memory bits 6 and 7. Alright? So we can simulate that here. So if we do load 93, so bits 6 and 7 aren't set because I think the number that we're going to be using is that one. I think that's 93, isn't it? Let's just do a quick calculator check on that. So binary 10010010. So that's 92. Yeah, 92. We'll go with that. 92. So we're going to load the accumulator with 92. So what it's going to do is bit 6 and 7. So that's bit 7 and that's bit 6. So bit 7 is going to get put into the negative flag, and bit 6 is going to be put into the overflow flag. So really we need to change that to a 1 as well, just to show what it's doing. So we'll figure out what number that is. So 11010010. So that's D2. So we'll put D2 in here instead, just to show. And then we're going to AND, we're going to bit with now we'll just check the addressing modes on this. So it's 0 page or absolute. Right, so we can't do an immediate, so we've got to test it with a value in the 0 page. So if we debug this program and have a look in the memory, oh, it's not going to do it. Debug. No, it's not going to do it. So we'll debug it with the 0. There we go. So we'll find an absolute value. In fact, we'll actually get it testing on 0801. There we go. We'll test it with bit 0801, which is 4C, and then we'll see what the end result is. So debug it. So we're stepping in. We're loading the accumulator with D2. Straight away, it's gone and said that the negative flag is set because it's D2, which is, you know, great. That's great. And then we're going to 0801. We're going to test it with 4C. Yeah. So we're going to see what the end result is. So bit, and straight away, because we've ANDed it with 4C, the top flag is 0, which is now putting, but the overflow flag is set because we've ANDed it with 4C and then ended the result. So as you can see, it's still D2, but all that's doing is we're testing the top 2 bits with 4C. Okay? That's why I've never used this command very often. It's a very strange command, that you AND the accumulator with memory, set the memory bit into that, memory into that, but the accumulator stays the same. All you're doing is testing the top 2 bits. That's all you're doing. You're testing the top 2 bits, and the result is not seen. All it is you're testing for those. Okay? The next instruction is branch if not equal. So these are pretty straightforward. So it's branching if Z, the registry Z, registry Z is set to 0. So it branches if it's not 0, and branches if it's plus, which is the same, the opposite to the minus. So it branches if the negative flag is set to 0. So that's pretty easy. And then we've got 2 overflow ones as well. So branch if overflow clear. So if the overflow flag is set to 0, or branch if it's set to 1. So they're pretty clear. Break. Well, what that does, it forces an interrupt and then pushes everything onto the stack. Even the status register gets pushed onto the stack. Clear the clary flag. Well, that's easy because we're just going to put a 0 onto the carry flag. Clear the decimal mode. Well, we're going to go into decimal mode in a bit, but there's another flag called decimal. And what that does, it allows you to do simple mathematics, simple arithmetic in the accumulator in decimal mode. So if you add 9 plus 2, the result, instead of it being a hex result of B, it gives you a result of 11. So we'll do that in a bit, yeah. We'll demonstrate that in a bit. Clear the interrupt. So basically, we can actually disable the interrupt by setting the interrupt bit to be 1. If you clear the interrupt, then you're re-enabling the interrupt to be working. And then clear the overflow flag, which allows you to set a 0 in the overflow flag. Now, I've just looked at the time and we're running into 25 minutes. So what I will do is we will call it an end on this particular video, and then we'll start again, and we'll continue from where we've set off. Alright, so from now I will say cheerio, and I'll see you in the next video.